and welcome to this latest DPA video interview. Today I'm with Chris Gumas, Director of Marketing at Ruland Manufacturing. We'll be talking about what to look for when specifying couplings. So Chris, what are some of the first things to consider when specifying couplings?
Customers will normally start with their bore size and the profile of the bore. So is it round? Is it round with keyway? Is it splined? They'll then generally look at performance. So what type of misalignment is in the system? What type of torque do they need to get out of the coupling? How much accuracy do they need? Do they need zero backlash or not? They'll then generally go to the envelope. So do they have any length or OD restrictions? Are the shafts movable on installation? That may determine whether or not they use a complete coupling like a beam coupling or an assembly type coupling like a jaw coupling. Is it a blind install, or are they going to have easy access to the coupling ends? And then also the operating environment. So what temperature is going to be present in the system, and is it going to be exposed to some sort of an extreme, like extreme temperature, or like sand or outdoor environment, chemical washdown, that sort of thing.
Okay, and what problems may occur when a coupling is incorrectly specified?
So there's really three main problems. The first is that the coupling itself will fail. We often see this in something like a bellows coupling, where the smaller bellows couplings, like the ones we make, are generally epoxied as opposed to welded, so they have temperature limits. And if a customer exceeds the temperature limit, which temperature isn't just a function of the ambient temperature, it's also a function of the RPM in the system. The higher the RPM goes, the more heat it creates, and that can actually melt the epoxy and cause the coupling to fail. There's also wear on system components like bearings or shafts, which you'd see with something like a rigid coupling in a system where the shafts are not perfectly aligned. You do need that perfect alignment in order to use a rigid coupling, and if you don't, you're not going to break the coupling. You're going to really put a lot of strain on your components. So something like your bearings may seize far before the end of their usable life. And then the third is excess wear on the coupling itself. Something like a jaw coupling, you're not going to break the coupling like you will a beam coupling, but you'll actually deform the spider to a point where it can't revert back to its original state, and that'll be permanent deformation. So you'll actually lose zero backlash, which is not going to be desired in a system where you want zero backlash. So you'll just see that wear pattern happen far earlier if you don't consider all the selection factors early in the design.
Okay, and following on from that, how can Ruland help?
So we have a website with a wealth of information. All of our product pages contain all of these factors that you would want to consider when making your design. We also have support videos such as installation videos, informational videos. We have a variety of different types of couplings which are available, and that gives users the broadest base of choices. So if they're used to using one type of style and they find that, oh, that's not going to work for my application, they can use something else. So that's why we want to have a wide offering. We also have chat support available, and it's you've got technical salespeople on there at all time. So you're not going to be, the first line of defense is not customer service, who's then going to send you to someone who's more technical. The first person you get is going to be able to answer pretty much any technical question that you may have, and that's critical because we're here in the States, so sometimes phone bills and everything, it's a little bit cheaper to talk with us on chat. We can also one button click there and do video chat if necessary, which is a nice little feature that we've had a few customers take care of. We also have easy ordering on our website. Customer can go on there, place an order. If the order's not in stock, we have fast turnaround. Generally, it's 1 to 2 day, and you'll have that product within the week, no matter where you are in the world.
Okay, do you have an example of the company helping a customer correctly specify the right coupling?
Sure. So we have an entire video series called the Collar and Coupling Corner video series on our website, and it specifically addresses customer issues. These are customer issues that we take right off our live chat and go and shoot a video on them. So I pulled 3 directly from there that I thought would be interesting. The first one is a customer contacted us with their disc couplings slipping on shafts. So there's a couple of go-tos, and the one that it ended up being was that their shafts were actually slightly undersized. Our tolerance is plus nothing, minus 13 micron. Their shaft tolerance was plus nothing, minus 100 micron. So about 7.5 times more than what our tolerance recommends. When you start getting out of the recommended shaft tolerance, especially on the low side, you run the risk of the coupling slipping depending on the torque in the application. So we recommended one of two solutions. The first one was use a different motor, either from the same manufacturer or different manufacturer. That way you can get the shafting within the right tolerance, or use a keyway, which if the coupling is going to slip, the keyway will prevent it from doing that. The customer chose to go with the different motor because it's a little bit easier if you're going to use that motor over and over again as opposed to modifying the shafts. The second one was, can a beam coupling be manufactured with a keyway? It's a common question we get with beam couplings. As a standard, the answer is no, and we generally try to push customers into a different style of coupling. The reason that you would want to add keyways to a coupling is because you want higher torque out of it. The beam coupling is not a high torque coupling. It's really a high misalignment coupling. So good for coupling something like a motor to a lead screw, where you're not going to have a ton of torque in it, but you still need the precision. So that's where beam coupling might be good. But in this case, you had a servo motor to a ball screw, both sides keyed. It was going to be too much torque on the beam coupling. So we actually moved them into an Oldham coupling, which is a pretty common shift for us to move someone into an Oldham coupling from a beam coupling if they're looking for the keyways, because the Oldham coupling capable of handling a little bit more torque. If you have a high peak torque in there, the Oldham coupling is rated in such a way that there's an operating torque for just the general use of the coupling and a static brake torque for that peak torque, so that as long as it doesn't exceed the brake torque, the coupling is going to be fine. And then we had a customer ask us, how should they couple two D shafts? It's common to see this on encoders where the shaft going out to the encoder from the motor has a D and the encoder shaft has a D. There aren't really standard D couplings that exist out there. All a D is it's a round bore with a flat in it. So it mates to a shaft that has the same profile. And generally a customer is fine using a set screw style coupling there. We normally want to lean towards clamp style. It's a better connection. It's a little bit easier to use, but in the scenario of a D, it's often better to actually use a set screw and connect the set screw right into the D profile. So those are some common questions that we have that have come up in the past, and some applications where we've been able to help customers out, get them into the right coupling.
Brilliant. Thank you very much, Chris. And to find out more about how Ruland can help you, please visit their website. All the details will be shared on screen shortly. Thank you.